Good evening, everyone. I'm going to explain about smart road traffic controller using an embedded system. Contents are introduction, architecture, communication interfaces, working, functional and non-functional requirements, advantages, conclusion, and references. Embedded system. First of all, an embedded system is nothing but a computer hardware system with software embedded or integrated in it. As an example of an embedded system, an embedded system can be a single unit or a component of a larger system. A system built on a microcontroller or a microprocessor and intended to carry a particular function is called as an embedded system. So basically, the embedded system can be divided into three parts. It has hardware components, software components, and real time operating system components. The real time operating system manages the application software and offers a framework to let the processor operate a particular task in accordance with schedule by adhering to a plan to control the latencies caused in the system. So, a dependable real time control system based on a microcontroller and operated by software is an embedded system. So, as an example for the road control traffic system, I'm using a system called traffic control done smartly using an embedded system. So the majority of the traffic control systems which we have in existence right now are not that flexible, and they can not be enough for a real time application. We can take the advantage of new smart controller approach that has just emerged in order to avoid such situations. It makes use of both embedded technologies and sensor networks. Traffic controllers function more effectively than traditional ones, and they also have simpler architecture. Next is the LCD display and other components required for the smart traffic controller system. The hardware components are the microcontroller. 89C5180 is the heart of the intelligent traffic system. It also contains input switching matrix, real time clock, the other clock circuits, infrared sensors, relay driver, and LED transferring units. So, the software components are the main programmable components of this system are embedded C, Kyle IDE, and UC Flash. Communication interface. Uh, there are different communication interfaces used in this particular embedded system, that is Wi Fi, Bluetooth, serial communication interface to cause the connections between the different circuits and multiplexers and adders. Application programs utilize the additional memory and ROM. To estimate the wait timings, we use reinforcement learning. The traffic controller's basic functions are carried out utilizing an embedded system. The infrared sensors are used to detect the vehicles. This serves as the TLC unit's input. Red, green, and orange output signals are produced by the ITLC unit. These signals indicate whether a vehicle is present or not. These digital signals will be supplied to the microcontroller's input and which will be used to calculate the volume of traffic in each lane. The microcontroller will choose the timing signals based on this information, and according to that, at each junction, the signal color should be red, red, green, or orange can be easily detected and displayed. Data mining also is a factor of the smart traffic control system, as it indicates a large amount of data that can be stored and required for the traffic analysis. Workflow and connections. Using the components of the embedded system designed, we can design it for various applications. For example, the connections for an emergency vehicle and the data flow. Non-functional aspects. Apart from the functional aspects, the non-functional aspects like the system should be highly reliable as it can cause major side effects, and performance level of the smart traffic control system should be accurate and moderate. The tools used in the system should be easy to design and flexible and user friendly. It also should have a future scope for intelligent traffic transportation system applications. Few examples of Few examples or advantages of traffic controller are average waiting time of vehicle. Suppose a vehicle is waiting at a junction and three other vehicles are waiting at three different junctions, and the estimation address and the estimated time is given by the user, and hence the traffic controller light will decide which vehicle has to be passed first and which has to be waited for a long time. An increase in signal switching frequency as opposed to fixed a traffic controller system. Smart traffic controllers will switch the signals more often. It is a dynamic system because as the signals are updated continuously, switching frequency is altered in response to the traffic. Conclusion. Modern traffic management and traffic control methods are largely responsible for improving traffic, avoiding accidents, and avoiding more waiting time for any vehicle. There could be emergency vehicles such as ambulance or a fire engine that has to be made space for first. The Project Smart Controller offers a robust hardware interface and features. Data mining is also used to access the data. The processed smart left light control is found to be more effective than a conventional controller in terms of shorter waiting time and higher switching frequency. The system also is user friendly, and it has a quick response time and room for expansion in the future. This not only solves the problem of traffic deadlock but also satisfies the environmental issues. Here are the few references I have used. Thank you.